Hello everyone. In this video lecture we are going to study about pipelining, right? Now what is pipelining? Pipelining is a technique of decomposing a sequential process into sub-processes, right? So suppose I'm having one process, right? So what I'm doing, I'm decomposing this process in the sub-processes. Suppose I'm decomposing this process in P1, P2 and P3, that is 3 processes, right? Now each of this process is executing using its dedicated segments, right? So the important word here is that is segment, that is used in pipelining, right? So each of the processes executed using its dedicated segment concurrently, right? That means the entire process is divided in subparts and each the parts can be executed concurrently using its dedicated segments, right? So why it is needed, right? So simple example I can take that suppose I'm having one process, right, that take 3 timing cycles to complete, 3 clock cycle to complete, right? Now I need to perform this one process for 100 numbers, right? So it will take 300 clock cycles, right? Now that that is large amount of time, right? Now using pipelining we can minimize this time, right? Now how we can minimize this time? So what we are doing, we are decomposing this process into, for example, let us say 3 parts, right? Now in this 3 part, first segment will do its own part, right? Now in the first cycle, first segment is executing its part, right, for the number 1, right? We can say task 1, right? Then it is only of one cycle because we are decomposing it, so each of the segment will take one cycle, right? Each of the segment takes time of 1 clock cycle, right? Now after this, after the task has been completed, in the second clock cycle it will be carry forwarded to the segment 2, right? At that time my segment 1 is free, right? So segment 1 can take another task, that is task 2 for the second number, right, and complete that task, right? And in the third cycle, at the end of the second clock cycle, the segment 2 will complete its work, right? So in the third cycle, segment 2 will forward that first task to the third cycle and it will take the second task and a new task is assigned to S1. Right, getting this, right? Now this is the block diagram of 4 segment pipelining, right? So we have divided our entire process into 4 segments, right? Now each of the segments here, that are S1, S2, S3, S4, right? Now in between there is a transition from segment 1 to segment 2. Segment 1 will complete its tasks and it will carry forward that data to the segment 2, and then segment 2 will proceed that task, and then after completion it will carry forward to the segment 3, right? But we are not directly transferring the data from segment 1 to segment 2. What we are having here, intermediate, we are having registers, right? So why there is a need of register? It might be possible that sometime segment 1 has completed its task but segment 2 is yet not ready, right? It might be possible, right? So as a buffer in between that we are having the register. So segment 1 will complete its task and store the value in register. Segment 2 will receive the data from register and then it will process it and store the result in register 2. Then segment 3 will receive the data from register 2. It will process the data, whatever execution is done. Then after that it will store the data in register 3 and so on. Right? Now along with this register there is a common clock is associated to keep the track of the cycles, right? Now we can take just real life example like assembly of any vehicle parts, assembly of a vehicle parts, right? So that is not done at one place, right? Entire car is not assembled by one person only or at a one place only, right? Different parts is assembled at different zones, right? So at a first zone it will complete some assembly part, then that will carry forward that part to the second zone, right? And first zone will do the same work again. Why? Because that can be minimize the time, right? So what we are doing here, that we are decomposing the task, and each of the segment will perform its own task only, right? So let us understand this, that by time space diagram. So suppose I am having 4 segment 1, 2, 3 and 4. This is my segment, right? And I am having a timing cycle, that is 1, 2, 3, 4, 5, 6 and 7. That is my clock cycle, right? This is my clock cycle, right? So at the very first cycle, task 1 is completed. Task 1 is in the segment 1, right? Segment 1 will execute the task 1, right? Now it will take only one cycle only to complete any of the task, right? So at the commencement of second cycle, the task 1 is completed its work in segment 1. So it will be carry forwarded to the segment 2, right? So in the second cycle, task 1 will be forwarded to segment 2, right? At the end of the segment 2, cycle 2, the task 1 will be carry forwarded to the segment 3, right? And at the end of the third cycle, that its work is completed, segment 1 is task 1 is forwarded to the segment 4, right? Now as you can see, at the second cycle, segment 1 is free, right? Segment 1 is free. So what we are doing in a pipelining process, we are assigning a new task 2 to the segment 1, right? So in a first cycle, task 1 is executed by segment 1. In the second cycle, task 1 will be forwarded to the segment 2, while the segment 1 will receive a new task called as task 2, right? Now in the third cycle, task 1 will be forwarded to the segment 3, right? Task 2 will be forwarded to the segment 2, and segment 1 will receive a new task, that is a task 3, right? Now in the fourth clock cycle, task 1 will be forwarded to the segment 4, right? Task 2 will be forwarded to the segment 3. Task 3 will be forwarded to the segment 2, and segment 1 will receive a new task, that is called as task 4, right? If you go for the fifth cycle, here we need not to worry about task 1, because task 1 is already completed at the end of fourth cycle, right? At the end of fourth cycle, my task 1 is already completed, right? Now what about the task 2? So in the fifth cycle, task 2 is in the last segment, right? Task 3 will be in the third segment, right? Task 4 will be in the second segment, and segment 1 will have a new task, that is called task 5, right? Now suppose if we have 5 tasks, we are just taking one example that we are having 5 tasks, right? So task 2 will be completed at fifth cycle, right? Task 2 will be completed at fifth cycle. If we carry forward this, here task 3, task 4, task 5. Now right now we are considering only task 5, so here nothing will be done, right? So task 3 is completed. Task 4, that is this is 6, this is 7, and here we are having 8. So task 4, task 5 dash dash, here task 5 dash dash dash. So in the eighth cycle, my task 5 is completed. That means in a 8th cycle, all the tasks, that is 5 tasks, are completed using pipelining, right? Now if we take a simple example, that in a normal procedure it will take a 4 cycle to complete one task, right? So for completing 5 tasks, it will need 20 cycles, right? Now if we compare this 20 cycle with this 8 cycle, there is a vast difference, right? Less than the half of the time, right? 20 cycle, the half time is 10 cycle, and we are completing 5 tasks in a 8 cycle only, so it's a less than a half time, right? So I think you are getting this, right? So that is the advantage of using pipelining, that is we can reduce the time, we can minimize the time for any process, right? So it's just as its name suggests, pipelining means what? Flow of data, right? We are transferring the data from one segment to the another segment, right? And so on, right? The earlier segment will receive another data, right? This data will be carried forwarded to the next one, this data will be carried forwarded to the next one, and here we are getting the output, and up to this segments will receive new data continuously. It is receiving the new data, right? So where it is useful, if we want to process some we want to execute some process, right? The same process for large amount of data, right? So at that time what we can use this entire pipelining process to give the efficient output and minimize the time limit, right? So I hope you all understand this basic concept of pipelining, right? In the next video lecture we are going to study about arithmetic pipelining. Thank you.